This is Advanced Math 12.6 homework questions. That's Advanced Math Unit 12, Lesson 6. These are the problems I'm going to go over here, and this is off of your worksheet 6, which is this one here. And starting off with number 6. On the worksheet for number 6, 7, and 11, it's asking us to solve for x. Be accurate to the nearest thousandths when appropriate. You will need a scientific calculator. Okay, now you have some like this on the test. All of these that I'm doing are similar to ones you would see on a test. Now, how do I solve for x? I have to look to see where is x. Is x a base? Is x an exponent? Is it part of a log? It's not part of a log, and it's not an exponent, it's a base. So I do want to get rid of that exponent by raising both sides to the reciprocal power. But I do have to get rid of that 15, and that's a mistake kids often make. They forget to get rid of the coefficient and they go straight to reciprocal power. So x equals, and I'm going to rewrite that as x to the 5/3 because the exponent is still there. X to the 5/3 equals 62 divided by 15 is not a whole number. It's a long decimal, I believe. We'll plug it in later. And then I raise both sides to the 3/5 power. Why the 3/5? Because when you have a power to a power, you multiply, and 5/3 times 3/5, they undo each other, and you're left with just x, and that there is what you would plug in your calculator. Okay, let's see if we can get that in. Okay, so I'm going to plug in 62 over 5, so I'm going to put that in parentheses. 62 divided by 5, close parentheses, and that's a 15, so I'm going to go back and fix that. Divided by 15, close parentheses. Exponent, my exponent key is over here by the x, right above the x squared key, raised to the 3/5, so 3 fraction 5. Don't use your division key, use a fraction key. If you do use your division key, you'll want to put parentheses around your 3 divided by 5 equals, and that is our answer there. 3 decimal places is 2.343. All right, next one. Solve for x. X is with the log, so I know I'm going to either drop the log or do a wraparound depending on the problem. But I want to get this log right here by itself first. So I'm going to multiply both sides by 1.5. And that's a multiplication. It'll kind of look like a power. It was not intended. Log of x minus 11.8 equals, plug that in your calculator, 3.89 times 1.5 equals 5.835. And now I'm going to add 11.8. So you should still have that 5.835 in your calculator. Just put plus 11.8. That gives you 17.635. All right, now is it a drop the log or wraparound? There is not a log on both sides, so I can't drop the log. It is a wraparound. Remember, whether you drop the log or wrap around, the log is gone. So the log will be gone in the next step. What's the base here that I'm going to wrap around? It's a base of 10. So 10 raised to that decimal, so x, 10 raised to the 17.635 equals x. Now I'm not going to plug that in the calculator because that's going to end up being a really big number, so I'm just going to leave it like this, 10 raised to that power. All right, next one, number 11. We are still solving for x. This is going back to a few lessons ago where in order to solve, I need to condense these two logs to a single log. Since it's addition, I'm going to do that using multiplication. So it's going to look like this. And then again, like the previous one, you ask yourself, is this a drop the log or wraparound? Either way, the log will be gone. And it is a wraparound because there's not a log on the other side. So I end up with 2 to the 5th power equals, I'm going to go ahead and distribute that, x squared minus 4x. 2 to the 5th power is 32. And I'm going to subtract that to the other side. 0 equals x squared minus 4x minus 32. Double bubble. X plus, x minus, x plus 4, x minus 8. X equals positive 8 and negative 4. Now, remember, if you're working with the log, you do have to check because you cannot take the log of a negative number. Okay, so I'm going to plug 8 here. 8 minus 4 is good. That's positive. Plug in 8 over here. 8 here. Log of 8 is good. That's positive. Negative 4 here or here doesn't work. Either place. If it doesn't work in one place, it doesn't work at all. Right here, log base 2 of negative 4 cannot do, so x equals 8 is our only answer. Negative 4 is an extraneous solution. All right, number 13 is asking us to solve for x in terms of y, and I did do something like this. It's different, but solve for x type problem in terms of y in notes. So I'm going to get the log by itself. That's y minus 10 equals log base 2 of 1 over x. And I want to get x by itself, and x is right here with the log, so I want to get rid of the log. Is this a drop the log or a wraparound? Either way, when I do a drop the log or wraparound, the log is gone. And it's wraparound because there's only one log on, there's only a log on one side. So 2 raised to the y minus 10 will equal 1 over x. 2 raised to the y minus 10 equals 1 over x. Multiply both sides by x to get it out of the denominator. So I have x times 2 raised to the y minus 10 equals 1. And I'm trying to get x by itself, so I'm going to divide by 2 raised to the y minus 10. Now, if you were doing this, if it was a test question and you wrote this as your answer, 1 over 2 raised to the y minus 10, I would be perfectly happy and that would be good. Now, if it's a multiple choice question and there's different ways to write this, which there is, you need to know there are other ways and what they would look like. If I want to bring this 2 up, I would take the opposite of the exponent. And since there's 2 pieces, distribute the negative. Positive 10 negative y is another way. You do not need to write it that way on your own, but if it was a multiple choice test question, you should know those 2 things are the same. Got it? Okay. Moving on to number 15. And number 15 is a word problem, and it reads, if $10,000 is invested at 7% interest compounded semi-annually, how much is the investment worth at the end of 25 years? Okay, so it didn't say compounded continuously. It's only when it says compounded continuously that you use the PERT formula. So that means we're using this longer one. And it tells us $10,000 is invested. That's our initial amount. P is always the initial amount. All right, 10,000 invested at 7%, that's our rate, 0.07. You can even write 0.07, it doesn't matter. And compounded semi-annually. N is the number of times it's compounded. Semi-annually means twice a year. And then it goes on to say how much is the investment worth at the end of 25 years? So T is 25. A is what we're looking for. What is the value after 25 years? A is the ending amount. Okay, so let's plug everything in. A equals 10,000. 1 plus rate is 0.07 over N is 2 raised to the N times T, so raised to the 2 times 25. A equals 10,000. Go ahead and plug that in your calculator. 1 plus 0.07 divided by 2. You should end up with 1.035. Raised to the 2 times 50 is I'm sorry, 2 times 25 is 50. At this point, you're ready to plug it in. So let's see if we can plug this in. I'm going to plug in 10,000 times 1.035 raised to the 50th power. And there's our answer there. After 25 years, it is worth $55,849.27. When you're dealing with money, you round to the nearest hundredths. Okay, so that's it for number 15. Moving along, number 17. When you read it, it says $25,000 is invested at 8.5% interest compounded quarterly. How long does it take for the investment to quadruple in value, accurate to the nearest thousandth of a year? Okay, another one that does not say continuously, so I'm using the longer formula. And let's read and figure out what goes where. $25,000 is invested, so that's your initial amount. Okay, at an interest rate of 8.5, so move your decimal over, that's 0.085. Compounded quarterly, that means quarterly is a quarter 4 times a year. Okay, what else is given? How long does it take? How long? We don't know, so that's what we're looking for. How long does it take for the investment to quadruple in value? It doesn't tell you what that is, and I did make a mistake, and I apologize if I confused anybody. I'm hoping you realized it was a mistake. P is your initial amount, and I'm not sure if I said it and wrote it wrong or what I put down. Okay, so P is the initial amount, 25,000. A is the amount we have after time T. We don't know that. That's what we're looking for. We're looking for the amount of time it takes for us to quadruple in value. They didn't give us the ending amount, but we know quadruple of 25,000 is 100,000. Okay, so now we're ready to plug it all in, and I have 100,000 equals 25,000 times, our parentheses, 1 plus R is 0.085 over N is 4, raised to the NT, so 4T. N is 4, T is what we're looking for. All right, so let's go ahead and divide both sides by the 25,000. Which makes sense. 100,000 divided by 25,000 is 4, because we're looking for the amount of time it takes to quadruple in value. And then plug that in your calculator. 1 plus 0.085 divided by 4 equals 1.02125 raised to the 4t. Now, where is my variable? It's an exponent. I need to bring it down. You can rewrite it in logarithmic form and then use your change of base. I'm just going to continue doing it the way I've been doing it in class or in videos, taking the log of both sides, not timesing by log, but taking the log of both sides. And I do that so that I can bring the exponent down using my log laws. My log laws allowed me to bring an exponent down to a coefficient, so my variable is no longer as a power. So log of 4 equals 4t times times log of 1.02125. I'm going to divide both sides by the log of 1.02125. Log of 1.02125, and this right here is what I'm going to plug in my calculator. 4t equals log of 4. Don't forget to close your parentheses. Divided by log of 1.02125 close or not close at the end, and you get this long decimal. Do not round it. You can write it. You don't have to write it all down. I'm just going to put 65.92 dot dot dot. It does go on. Don't clear it. You want to leave it in there to divide by 4. You don't want to round and then divide because your answer will not be accurate. Divide by 4, and I get 16.482, and it said thousandths place. So T equals 16.482 years. So it'll take almost 16 and a half years for us to quadruple the amount what we started with. Okay, number 20. Number 20 reads, what initial investment is needed to reach a goal of $500,000 if the investment is at 11% compounded continuously for a total of 20 years? So now that it said continuously, now we can use the PERT formula, and let's see what it's giving. What initial investment is needed? So that's what we don't know of initial investment. To reach a goal of 500,000. So we want to end up with, that's our A amount, 500,000. Does it give us a rate? A rate of 11%, which is 0.11, compounded continuously for 20 years. So we know we're going to compound continuously for 20 years. We know the rate. We know how much we want in the end. So how much money would we need to put in the bank to start with to end up with $500,000 in 20 years? Okay, so we'll take a guess and then we will try. Okay, 500,000 equals P, we don't know. E is just E, raised to the R, which is 0.11 times 20. Okay, this right here is just a decimal in your calculator. Kids often freak out, like, I don't know what to do. Am I going to log both sides? No. P is your variable, and P is not an exponent, so there's no need to log both sides. And P is by itself. There's no exponent on it that you have to reciprocal power. You're pretty much just going to get rid of this decimal. This decimal is a decimal that's hiding in your calculator, so let's figure out what it is. Okay, to get to my E key, I hit second LN because the E key is above the LN key. Then I'm going to put in 0.11, and it gives me parentheses already, so 0.11 times 20. And I end up with 0.9025, blah, 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 blah. I'm not going to clear that. Do not clear it out of your calculator. So I have 500,000 equals P times 9.025, blah, blah, blah. I'm going to divide both sides by that number. But when I divide it in my calculator, I'm going to divide by second answer. Remember, we've done that before. So you're going to plug it in, 500,000 divided by second answer, so you have that long decimal in there, you don't have to retype it, and you end up with 55,401.58. So that's how much money you would have to take to the bank. You would take $55,401.58 to the bank, compound it continuously at 11% for 20 years, and then you would end up with $500,000. Okay, that is it for number 20. And lastly is number, what did I say, 21. Okay. In 1983, the United States government agreed to pay the Native American Pequot people for land that they owned in 1856. The Pequots asked for $900,000. A government official suggested that the Pequots be paid the value of the land in 1856, which was $8,091.17 plus interest. A, how much was the government official offering the Pequots in 1983? Considering the average 1983 interest rate of 10% compounded continuously. Whew. Okay, so 1983, And what was the 1856, it was worth $8,091.17. So in 1983, the Pequots asked for $900,000, so almost $1 million, and the government said, no, we'll pay interest and da 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 da. What is the government offering them? Okay, so it said compounded continuously. Part A is A equals PERT. Sorry, A equals PERT. Okay, so what is the initial amount? What are we ending with? Well, we don't know what we're ending with. That's what we're trying to figure out here. How much do we have after a certain amount of time? What did we start with? Well, what was the amount of their land in 1856? $8,091.17. And I believe it's that the rate was 10%, so that's 0.10 or just 0.1. How much time has passed between 1856 to 1983? That is a total of 127 years. All right, so let's plug it in and see what we get. How much is the government offering to pay them for their land? A, we don't know, that's what we're looking for, equals P, $8,091.17 times E raised to the 0.10 times 127. Now, all of this is just a number from my calculator. I don't have to solve for anything over here. A is already by itself. I'm just going to plug everything in my calculator. 0.10 times 127 is 12.7. And now we're just going to plug all that in our calculator. Okay, $8,091.17 times second ln key for my E key raised to the 12.7 power. Wow, a lot more. So let's write that number down. This is 2,651,863,991. Wow. Is 2 billion a lot more than close to 1 million? It is. A billion compared to a million is big. Think of it this way. 1 million seconds is about 11 and a half days, so we'll just round to 12. 1 million seconds is about 12 days, where 1 billion seconds is about 31 and a half years. That's a big difference. I'll repeat that. 1 million seconds is about 11 and a half days, where 1 billion seconds is 31 and a half years. So the government was paying this much, where the Pequots were asking for 100,000 or 900,000. Big difference. Okay, part B. Find the interest rate compounded continuously requested by the Pequots. Okay, so same formula. The Pequots were requesting 900,000, so now we're going to plug that in for A. The initial amount was still $8,091.17. The rate, we don't know. We're wondering what rate were they using when they figured out the 900,000, and the time is still 127 years. Okay, 900,000 equals $8,091.17 times E raised to the R, we don't know, times T. All right, I am going to divide both sides by the $8,091.17. Okay, so go ahead and plug that in your calculator. All right, I am not going to round. I'm just going to write the numbers down, leave that number in my calculator, 111.233 dot, 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 equals e raised to the 127r. Okay, what am I trying to solve for? I'm trying to solve for r, and r is a power. So I need to bring that power down by either rewriting in logarithmic form or taking the log of both sides. I like to take the log of both sides, but in this case I'm going to use ln. ln of 111.233, that number's in my calculator still, I'm going to leave it there. ln of e raised to the 127r. This 127r is going to come to the front. ln of 111.233 dot, 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 it's still in my calculator, equals 127r times ln of e. Now we've done this a few times and I'm hoping you remember ln of e is just a big 1 in disguise because ln of e is log base e of e, which is 1. Okay, so I'm going to divide both sides by 127. And now I'm ready to plug it in. ln of that number that I still have in my calculator, there it is right there. So ln, second answer, close parentheses, divided by 127 equals 0.037 or 3.7%. I'm going to write it like that because that's usually how they give an interest rate. So they were asking for 3.7% where the government was paying it with 10%. Big difference. Close to $1 million versus $2 billion that they ended up with instead. Okay, so you see real life applications of mathematics being used. It may not be something you would use while you're shopping for groceries, but it's still math that is used. That is it for this section of homework questions.